Hey, what's up? Doing a little devlog here today, and there's actually not that much to say, but maybe it'll end up being a lot somehow. But I was experimenting with materials a bit, and that's something that anyone should do. Oh, hello. Somebody joined. Hi. Okay, so I'm just gonna say just recording a vlog. Okay, so this actually is an AI generated material, and let's see. Yeah, so in Roblox Studio, it's a beta feature. So you can add it, and maybe I'll show that later, I don't know. But this was generated by AI. And sometimes the AI will generate stuff that looks like images, like as if they were taken by a camera or something. So it looks like kind of 3D in a sense. And so I'll sometimes put flat in the description. Basically, you write some text, and AI will generate the texture for you, or the material. And so this one, if I make it wider, it will just repeat. So I left it at this size. I don't know what this is supposed to be, but it's got interesting texture. It's got interesting stuff going on. So that's kind of cool, I guess. Okay, this one also AI generated. So it's, interesting stuff. That one over there was AI generated, but I don't think it's very impressive or whatever, so I mean, it might be okay if not on this enormous sphere. This is not AI generated. This is just some random material. Well, I guess this is old school Roblox brick material or something. This is AI generated. It looks all right. It looks a little dark. I'd like to brighten it up a bit. This also, so I asked AI to make some lava. If I'm not mistaken, this is AI generated also. And the thing is that, well, it looks rather nice, I think. And I added a light to it, so it sort of glows a bit. But no matter what, it will look flat when viewed from the side here. So what I want in order to make it look better is I want a displacement map. And so it's not super complicated, but it's not trivial either to add something with a displacement map. I think it's not really built into Roblox Studio, this like handling displacement maps. So you kind of have to kind of do it manually in a sense, where you, for example, you turn the displacement map into actual geometry, an actual mesh, and then export that out of, say, Blender and import. So that's what I was looking into, and it's kind of a pain, to be honest, but there are ways. So like, say, given this texture, there are ways to sort of automatically produce a displacement map. It won't, those automated ways, sort of algorithms, won't always produce what you want. Like it has to guess what is sticking out and what is sort of falling in, if you will. Now they might have gotten better in recent years because it's been some time since I've played around with it. But like with AI now, maybe, I don't know if anyone's doing an AI generative displacement, or an AI displacement map generator or something like that. It could be smarter than before. But anyway, the point is, like, it will give you something, but it might be in need of fixing, which, if you're just looking for to give this some overall pop, like make it pop out a bit so it's not so flat, then, and usually people aren't like dissecting your textures, looking at it from this angle, but if you're just looking to add a bit of pop and a bit of character, then I think that it might be okay to sort of have this algorithm that generates the displacement map and then just sort of fix it. Like things might be going in the reverse order. You can learn how to fix it. I'm looking at this and I think there's a normal map on here. I think. But I'm not totally sure. I think there are normal maps, but there's definitely not displacement maps. Displacement maps will actually show sort of geometry sticking up here so that the silhouette, it affects the silhouette of the object you're looking at. So that's what I want to learn. Now it is a bit of a pain because like if you're building a whole map, then, I mean, it doesn't need to be for every texture, but if you want to use that for a lot of textures, it'll be a pain. Also, the collision detection always has to be a lot simpler. Like one tutorial I was looking at, I don't know, I might edit it in to the video, but to show you what I'm talking about, but they were looking at adding almost 10,000 triangles just for one surface. I think that's very excessive, but for collision detection, things need to be much, much simpler. I've talked about that in previous devlogs. You don't want like something with 10,000 triangles in your collision detection. It creates way too much computational overhead, okay? Anyway. So, but even if you had some somewhat complicated geometry on here on the surface, but if you, for the collision detection, you just model it as a box, I mean, that's probably enough. You don't want it sticking out super far, necessarily. Or if you did, well, yeah, that's not, if you had something sticking out really far, that's a mesh. I mean, at what point is it just a mesh, and at what point is it a displacement map? Kind of is, I guess, up for debate. It's a semantic debate at some point. Anyway, going to show you something else, maybe real quick. Just also looking at, how do I show like my most recent things that I played or whatever? Whatever. Let's just go here. That's not where I want to go. Oh, it's showing it now, isn't it? Okay, so there was one. Let's see here. There was one with some water, which was interesting. For some reason, it's disappeared. So I guess I can't show you that. But somebody had a very interesting, like, realistic ocean thing going on. Can I find that somehow? Hold on, sorry. I may not feel like editing this video. I apologize. But yeah, it's not gonna show. Did I edit? Maybe I added it to my favorites. I don't know. By the way, most of these I haven't played. They're just like listed out for sort of research purposes, if you will. I think I probably added it to my favorites. Anyway, let's search for it, I guess. Realistic water, maybe. Yeah, this is the one. The ocean experience. So in my studies of materials, I'm interested in glass and then also water. Now, these are kind of special things. So let's have a look-see here. I'm going to turn down the desktop audio just in case that's annoying here. I'll just do a speedboat. Now, interestingly, the performance is not that great. I have a pretty decent graphics card and a pretty decent CPU. Plenty of RAM. And you'd expect the performance to be a bit better. If this were a AAA game, this would be terrible performance. But, you know, because everything is built on this sort of layer of Roblox, then you don't end up necessarily with the best optimized performance. But as you can see, one nice thing is that first of all, the water is transparent. And people have said online in the dev forum that if you turn up your graphics settings, that the ordinary water in Roblox is transparent. But it seems to kind of depend. I don't know. But sometimes I want the water to be transparent. Especially like if it's a shooting game, I would like for you to be able to see into the water and be able to shoot at people in the water, not so they're not hidden or whatever. And then of course we have this kind of bouncing texture. And is there a real geometry here? Yeah. It's not just a flat surface with a normal map. It's actual geometry. So, of course, making water is a very common thing in game development, and well, it might seem a little bit overwhelming, how to make this kind of geometry. It's a problem that's been investigated quite a lot, and I don't know, I'm interested in doing this kind of stuff, making some better looking water. Definitely, like I said, the transparency is kind of a priority, but then also having actual geometry is something that definitely interests me. But these are two separate but related things, like just learning how to do better textures that have displacement maps is one thing. That would be a huge step up, I think, for me. And then secondly is water. These are kind of separate but related things. Ragdoll engines. Huh. Lots of realistic demos and stuff. Oh, this is interesting. So this is from Roblox, huh? I'll have to check that out later. That sounds interesting. Okay. And I'll show you some weird stuff I was playing around with. Just some kit bashing I was doing here. Let's see here. Creations. I'm going to clean this up a bit because there's a bit of... This strange physics thing is really weird. Maybe I'll show that too. There's kind of a bug in how the sky works with the sun and the moon and all that that you can see in here. I need to improve the thumbnails and then remove anything that's really super boring and a waste of time for people. What was I going to show? Not this one. Area only Skybox. This is something I copied from someone, and it's where my wife is getting angry at the cats. It's where you can walk through something and the skybox will change. So that's interesting. And I was kind of looking at more to do more dynamic stuff with the skybox. And in particular, let's load up this and I'll kind of say what I'm looking for with the skyboxes. So being able to have a skybox in general is one milestone with game development. And now, if with something like Unity or this thing, Roblox, having a skybox is trivial. But if you were developing... did you see the lighting when the eagle passed between us and the sun? There's some god rays. That's actually really cool. So what's weird here is the sun is in the sky and it's nighttime. Okay, this is bizarre. There's these those orbs are just for looking at materials. But this is clearly a bug. Now, this is created because I'm playing not only with the time of day, but also with the latitude number. So I might talk about that some other time, but it's very strange to me. This is a bug, a Roblox bug. So I got to figure out what was going on there. Now it's probably easy to avoid this bug. but I got to figure out what's going on. So I don't know. I was just playing around with some random stuff. These smaller balls are more easy to kick around. Bigger ball has more inertia. Let's see if we pick up the rocket launcher. Do they? I think these move in response. Oh no. Okay. They don't move. Anyway, I was just playing around with some stuff, and but this bug with the sky, where you can have the sun out and it's still nighttime, it's very strange. So thought I would share that. Is there anything in the water of interest? Not really. There's a fish. Fish is from the forest pack by Roblox. I will note that I think if you're interested in animating certain meshes, if you're interested in getting an animation, like having characters walk and stuff, a fish is actually a really good starting point, because I've seen tutorials where fish are extremely easy to animate. So maybe even like making a shark or a whale shark or a whale or a dolphin, but starting out very simple might be an excellent way to get started with some animation, character animation or whatever. There they are, they're back again. So, okay, what was I going to say? With the Skybox, so I had, right now you don't have it, but there was a Skybox or 2 or 3 that I was playing with where you have you have Earth below you. So it's supposed to be like you're orbiting Earth or something like that. And the thing is, it's static, right? The Earth isn't orbiting or anything like that. I would like to have more control over the Skybox. Now the Skybox really, it's just it's a cube around you, around the camera, where the faces of the cube are sort of at infinity, if you will. So as you're moving, the position of the cube in general stays put. So it's at a distance of infinity, but it's still getting rendered, because some things will, if you put the distance at infinity, it will clip, so it's not it's not getting rendered because it's too far away. There's a rendering distance normally, right? So it has to surpass that in some way. Now you might also be thinking, some of you who know about programming a bit might be thinking, well, how can you have something at infinity? Well, there's 2 ways. I'll say the dumb way that's sort of irrelevant first. In the C programming language, which is sort of foundational, and many other programming languages are based on it, in C, there is a thing, think of it as a label or something, of infinity in certain cases. And so there's some special treatment of infinity that you might look into, but that's not relevant to our situation. What actually happens is, if you're building a renderer, I can't get into all of the details of it right now because it's slightly complicated, but basically, we're positioning things in 3D. And there's some mathematical tricks where you actually use a 4-dimensional system, and you project it. It's sort of you use projective geometry, okay? And so it's technical, but I'll just say it because I do not know how to say this in a non-technical way, but if you want to do translations are not linear transformations, and we want to use matrices to do our translations and other kinds of transformations. And matrices are always linear transformations. So if you have all possible linear transformations and then you add onto it translations, I think that that's the set of affine transformations.
also pronounced affine. I think normally it's pronounced affine, maybe. Affine transformations are basically the ordinary linear transformations plus translations. So translations are not linear transformations because they move the origin. And so in order to sort of, well, it's a beautiful, fantastic mathematical trick that we can add a dimension to our space, and we can do, for example, we can do translations in 3 dimensions by doing linear transformations in a 4-dimensional space. So yeah, so it's a trick, I guess, and it's using projective geometry, but it's also it's normally referred to as homogeneous, a homogeneous coordinate system. So probably, shadow is looking nice. Some dynamic shadow stuff going on. I wonder if I get this in Roblox Studio when I play around as well. Not sure. I need to check that. So, and you can see those shadows below me as well. So yeah, it's called a homogeneous coordinate system. I'll probably talk about this in the future. It's rather technical for most people's use cases, I guess. I don't want to be too overwhelming, but yeah, that's how we do translations in games, really. I mean, there are simpler ways, and if you're doing a 2D game, it's really overkill. You don't really need to do that. I mean, you can. It makes the mathematics neat. It's a nice, neat mathematical package so that you can use... Basically, the beautiful and powerful thing is that matrices, you can just multiply them together in order to sort of chain a series of transformations. So if you rotate an object and you translate it, in other words, you position it somewhere, you can represent both of these transformations with matrices, and then if you want to do both of these transformations in order, you just multiply the matrices and you get one matrix. And then this is very computationally efficient because you can take that one matrix and apply it to all the vertices of a mesh. And so that's what happens in the graphics card. So you have a CPU and a GPU, and basically the way to think of it is that the CPU is a machine that is very good at doing a wide variety of different things. Now in the old days, CPUs only had one processor. So like when I was growing up, we didn't have multi-core processors. I think that started, maybe 15 years ago-ish? And now you have CPUs with, I think this one that I'm on right now I think it has 4 cores. Okay, so basically that means you can have 4 separate threads. So I'm getting a little complicated and technical and all that, but basically, think of it this way. If you have only one thread, and if that thread, so it's one process, and if that gets stuck, for example, in some kind of loop, like a for loop, and if a while loop or a for loop, it doesn't really matter, any kind of loop, and if it gets stuck there, which means that your process is going through that, iterating through that loop, and it's an infinite loop. You made a mistake and it never exits the loop. Then that thread will basically get stuck in that infinite loop, just going over and over and over and over again, and will never get out of it. So if you have a single thread, if you have a single core, so the core refers to what, like physically how many threads you have. Well, physically, it's sort of the physical version. But when we talk about threads, the thing is you can take one core and then sort of simulate as if you have multiple cores, multiple processors. So even on one core, you can divide it up into more threads.
So there's I think it's the kernel. There's this thing called a kernel in the operating system. And I think in the kernel, it will sort of divide up the CPU workload. It will be divided into multiple threads. So that's sort of software based. That's software-based multi-threading. And then what's it called? I think it's sometimes called hyper-threading, at least with the Intel CPUs. I think it's called hyper-threading. So my processor is 4 cores, but because of this sort of software-based multi-threading, it has 8 threads. So I believe that's called hyper-threading or something like that. I have an Intel CPU. So there's 8 threads on this system, I think. Okay, so the GPU is different in that it's like as if... So the origin of the problem is that we have a display. This display is full HD, so it's what, it's 1080p, so it's 1920 by 1080. The width is 1920. When you multiply that out, it's roughly 2 million pixels. So if you want to do an operation for every pixel, that'll be 2 million operations. And let's say you actually want to do 20 operations per pixel. Well, now you're at what, about 40 million operations. And if you wanted to do that, say at a rate of 60 frames per second, gosh, we're getting, I said it was 80, now 60 times per second. What is that? 8 times 6, 48. I don't know, but I think it's like 4.8 trillion operations per second or something. And so what I'm saying is that's an enormous amount of operations. And if you had one thread doing that, basically it's going to be stuck. When you're doing sort of low-level game development stuff, like if you're building your own engine, you can play around with doing software-based rendering. What that means, it's sort of silly terminology, but we often call things software-based if they're on the CPU, and hardware-based or hardware-accelerated means that we have a GPU. Don't ask me why. That's just terminology that is often used. People talk about hardware-accelerated graphics rendering. They just mean that you're making use of the GPU. But you can experiment with software-based, and you'll get much lower frame rates of like 2 frames per second or something like that. Because the CPU only has so many threads. It has, depending on your CPU, maybe 4 threads or 16 threads or 32 or whatever it is. So, but the GPU, the idea is that it can do much less variety of different things, but it has many cores. There'll be like tens of thousands of cores in modern GPUs. So, and in particular, it's optimized for matrix algebra, basically, matrix-based operations. So, long story short, in order to position something on the screen, pretty much everything is going to have a matrix associated with it. You at least want to position something and then rotate it, give it some sort of orientation. So the positioning, that's a translation, which is normally not a linear transformation, but we use a mathematical. So when I say it's not a linear transformation, that means that you could not possibly use a matrix to describe that transformation. All matrices keep the origin where it is. There's no translation. There's no just simply shifting things over. But we use this trick of adding a dimension and then using the projectivized coordinate system, which is often called homogeneous coordinate system. We use this trick, in order to turn the translations into linear transformations, where we can use matrices. So we use that, and then the rotation is rather straightforward with the matrices. Those are always linear transformations. But we apply both of these to every object, and then you'll have you have like a world transformation sort of, or anyway, you have a world transform or a camera transform. I think it's a little more straightforward to call it a camera transform. But what's really happening normally, the math is much simpler if you keep the camera stationary and you move the world around the camera. That just makes the math much more straightforward and probably computationally more efficient. It's kind of the only way to do things, I think. So while it looks like we're moving around in the world, it's actually the world moving around us, or moving around the camera. The camera usually stays static, actually, when it comes to how you actually calculate things. So there's at least 3 matrices usually being multiplied. Or really 4, because the camera transform has usually 2 matrices associated with it, the translation matrix and the orientation matrix. And then every object has its own translation matrix and orientation matrix. So for every object, you typically have these 4 matrices. Again, the beauty is that you can take these matrices, multiply them together, and then get one matrix. So, for example, as long as this object doesn't move, we have this translation matrix and an orientation matrix. We multiply it once, and then we hold on to that data. We don't need to keep recalculating it until the object moves. When it moves, we recalculate the matrix for that object. And then separate is the camera matrix, if you will. But anyway, so it depends on your implementation, and there's, it's a bit complicated and all that, but this is sort of the fundamental math that has to be done in order to calculate how to render things. There's also this projection matrix, which is what takes everything in 3D and flattens it onto a 2D screen, if you will, 2D plane. And that only depends. There's certain parameters with that, like, I don't want to get too into the details, but there's that's a linear transformation. So you can do it with a single matrix. And usually that won't change if you want to change your field of view, for example, you will change the projective transformation that you're using, the matrix that you're using for that. So yeah, there's all these matrices, they're getting multiplied, and so what you do is you sort of hand off these matrices to the GPU. GPU has its own RAM called VRAM, and stores that in VRAM, and then there's going to be a whole lot of multiplying of, it applies these matrices to, for example, vertices. This sphere, you can see the edges of the sphere. It's not a perfect sphere. It's actually some kind of icosahedron or something like that. It's made out of triangles, and each vertex. So when I was talking about, for example, the local transform will have this local transformation matrix and local orientation matrix. The product of that, you'll take that matrix and apply it. You'll apply it in the same way to every vertex in this object, so that every vertex gets this transformation applied to it. And so, if you had a complicated mesh with thousands of triangles, and then thousands of triangles, that means thousands of vertices, and you want to apply a matrix to each of those vertices. So that's what the GPU does, because it's the GPU and CPU are designed to solve very different problems. So I don't know how I got onto this long-winded explanation of all that. I forget what my original point was, to be honest. I think that's going to happen a lot with me. But there will be more videos in the future to explain all that stuff. This kind of low-level graphics programming stuff. Yeah, I think I was talking about the Skybox. So I talked about that there's this thing called homogeneous coordinates, which is this kind of mathematical trick where we use a four-dimensional system, even though we're really only trying to do things in 3D. Well, in that system, you can have points at infinity where we actually just use the value of 0 to represent points at infinity. And so you can do that with the Skybox. So the Skybox, yeah, so it's a special, you generally make use of this sort of special system. But anyway, I want to dynamically change things, which the Skybox is a box, and so it's 6 faces, and so it's 6 images, and there's a way in Roblox to dynamically alter images. That's what I want to do. So, for example, if I want like a comet to fly across the Skybox, then I want to... I mean, I could just put that somewhere in the world that's far away, but the further away I put it, it will have like a clipping distance with the camera and all that. The really good way to do it would be to sort of project this comet onto the Skybox and then have it move around. So it's a little complicated to do, but I am good at math. I'm good at that kind of stuff. It sounds like an interesting problem. Or another, a simpler case would just be to sort of, kind of like how they have these stars that show up, to kind of implement that myself, have sort of twinkling, glowing stars where their brightness varies a little bit. That'd be easier because you don't have to worry about positioning of anything. The rocket launcher, you can only get it when there's only one rocket launcher in this game. So anyway, yeah, I want to play around with Skybox is one thing. The displacement maps I'm working on, and one thing with that is there's this thing called Adobe Substance Painter. Adobe Substance Painter, I mean, it's an Adobe product, so it's expensive. It's probably like $20 a month. But I believe in that program, they're called height maps. And anyway, it'll have to be another video or two to talk about it, but it's like the really super professional way of making textures, I think. And so if I can figure out a workflow where I can make textures in there, and I believe they probably have AI stuff in there too. So, but it's, yeah, like I said, it's probably the most professional way. Or there's also Zbrush. There's other software out there. So Zbrush or Substance Painter, making the textures, outputting some kind of displacement map, figuring out how to import that displacement map into Roblox, which it's just going to be importing a mesh because Roblox Studio doesn't have stuff for the displacement map. It doesn't have that stuff built in. Yeah, but figuring out that will be the way to get the most professional looking textures that I could possibly make. There's also a trick with sort of trying to avoid this very repetitive look. I'll have to talk. I don't even remember what it's called, but I've seen tutorials on it in Blender. Yeah, you have these textures look repetitive, right? There's ways to build out things where it's kind of things are kind of rotated almost like a kaleidoscope or something. It's hard to explain. But there's a trick for avoiding much of the repetition in textures. So that's another thing. And let's see. So yeah, that's what I'm looking at to get. Because I'm just, like with the lava that I showed earlier, as long as that's flat, it doesn't have any geometry to it, it's never going to be totally satisfying. So I want to get the displacement maps going. And I want to get a nice workflow with that. And it's important to not go crazy with that with like 10,000 triangles on every texture. I want to keep it sort of simplified, like almost like a low poly displacement map. But I think that's very reasonable. It's not going to factor into the collision detection. The collision detection needs to be modeled with much simpler geometry. And that's fine. But I want the textures to pop a bit more. And then looking at better ways of rendering glass, better ways of rendering water. So it's the normal map that allows, there's a normal map and a specular map that allows this nice shading on the surface here. But the normal map doesn't pop out. The silhouette here is flat. If I had a displacement map, there would be, it wouldn't, when I look at the surface like this, you would see geometry there with the displacement map. That's what I want. And yeah, more beautiful water. And possibly dynamic skyboxes where I play around with that myself. For like a comet would be great. Or if you have Earth below or like a space station below and it rotates, for example, that would be awesome. And again, just because I'm not sure if I made this clear, if I had like a space station down there, I could build the geometry and just import it like a mesh. But you get into the clipping distance with the camera, and that will depend on the individual's graphics settings. So it will not be the way you want it to look. The ideal way, I think, is to render it onto the Skybox itself. And I mean, that's what they're doing with this stuff. This is a dynamic Skybox, right? Yeah. So I guess those three things, those are kind of heavy duty things I was looking into. Yeah. I don't know. It interests me. It's good. Good stuff to learn. It's not easy. It's not trivial. It's a bit complicated, but it's good stuff. So I'll let you know. I definitely found a tutorial that allows me to import the displacement map from, say, Blender into Roblox. So there's definitely ways to do this. I'm almost 100% sure about that. And as we saw that demonstration of more realistic looking water, so that's definitely possible. And the dynamic skybox is definitely possible because that's what we're looking at right here. Now that's a weird bug. That is the sun out at night. So that's some stuff with the latitude. And maybe I'll show that another day. I'll make like a quick video only demonstrating this bug, and I'll show the code involved. It's simply playing with the time of day and the latitude, and you get this weird bug. That's it, and this was a bit long, but that's how I roll sometimes. So let me know what you think. Let me know if you have any questions about Roblox Studio or Japan or mathematics. Please do let me know in the comments, because over time I'm going to need ideas for videos, and if people are giving me ideas, that would be extremely helpful. Okay, that's it. Thank you and goodbye.